Machine learning best practices for real-world projects. Machine learning (ML) is the process of building systems that learn patterns from data and make predictions or decisions automatically. Real-world ML projects involve much more than just training a model. They include, data collection, data cleaning, feature engineering, model training, evaluation, deployment, monitoring, retraining. A common interview question is, what are machine learning best practices in real-world projects? This guide explains ML project lifecycle, real-world ML architecture, data best practices, model training best practices, deployment strategies, MLOps concepts, monitoring and retraining, common mistakes, production challenges, best practices used in industry. This is one of the most important topics for ML engineers, backend developers, data scientists, and AI engineers. Simple definition. Machine learning best practices are proven techniques and processes used to build scalable, accurate, maintainable, and production-ready ML systems. Why best practices matter. Good ML practices help teams. Improve model accuracy. Reduce production failures. Handle large-scale data. Maintain reproducibility. Deploy models reliably. Monitor model performance. Without best practices, models become unreliable. Predictions drift over time. Deployments fail. Experiments become impossible to reproduce. Technical debt increases. Real-world machine learning lifecycle. Typical ML workflow. Business problem down. Data collection, data cleaning, feature engineering, model training, evaluation, deployment, monitoring, retraining. 1. Define the business problem clearly. The first step is understanding what problem we are solving. Check. Business goals. Check. Success metrics. Check. Constraints. Examples. Check. Fraud detection. Check. Recommendation systems. Demand forecasting. Customer churn prediction. Image classification. Bad practice. Negative training models without clear business goals. Good practice. Define measurable objectives first. Example. Goal. Reduce fraudulent transactions by 30%. 2. Data collection best practices. Machine learning depends heavily on data quality. Good data should be accurate, consistent, relevant, representative, sufficiently large. Data sources. Databases, APIs, logs, sensors, cloud storage, streaming systems. Example. Application logs, data pipeline, training dataset 3, data cleaning best practices. Real-world data is messy. Common problems. Missing values, duplicate records, inconsistent formats, corrupted data, outliers. Best practices. Check. Validate data early. Check. Standardize formats. Check. Handle null values carefully. Check. Remove duplicates. Check. Detect anomalies. Example in Python. df.drop duplicates in place equals true. df.fillna 0 in place true. 4. Feature engineering best practices. Features strongly affect model performance. Feature engineering includes normalization, encoding categorical values, scaling, feature extraction, feature selection. Examples. Age, income, purchase history, login frequency. Best practices. Check. Remove irrelevant features. Check. Avoid data leakage. Check. Create meaningful domain-based features. 5. Split data properly. Datasets should be separated into training set, validation set, test set. Typical split. 70% training, 15% validation, 15% testing. Why? Check prevents overfitting. Check ensures fair evaluation. 6. Avoid data leakage. Data leakage occurs when training data accidentally includes future or hidden information. Example. using future transaction status during fraud prediction training. This causes unrealistic accuracy, production failure. Best practice. Ensure training data only contains information available at prediction time. 7. Choose the right model. Different problems require different models. Problem type, common models, classification, random forest, XGBoost, regression, linear regression, NLP transformers, image recognition, CNN, time series, LSTM, profit. Best practice. XBot simple, before using complex deep learning models. 8. Use cross-validation. Cross-validation improves evaluation reliability. Example, dataset dash multiple training validation splits. Benefits. Click more stable accuracy estimates. Click better generalization. 9. Track experiments. ML projects require experiment tracking. Track hyperparameters, model versions, metrics, training time. Popular tools. Yes, MLflow, weights and biases, Neptune AI. Example, experiment. Learning rate equals 0.001, accuracy equals 94%. 10. Use version control. Version. Code, datasets, models, configurations. Tools. Check, Git, DVC, data version control. Benefits. Check reproducibility, check rollback capability. 11. Automate ML pipelines. Production ML requires automation. Pipeline stages. Data ingestion, feature processing, model training, evaluation, deployment. Tools. Peerflow, Kubeflow, Jenkins, GitHub Actions. 12. Monitor models in production. Models degrade over time. Reasons. User behavior changes, business changes, seasonality, concept drift. Monitor. Prediction accuracy, prediction latency, prediction error rate, prediction data drift, prediction model drift. Example. Production predictions. Monitoring dashboard. 13. Handle model drift. Model drift happens when data changes over time. Example. Check fraud patterns evolve. Check customer behavior changes. Best practice. C. Retrain models periodically. 14. Build scalable ML systems. Real-world ML systems must scale. Use IS, distributed training, GPU acceleration, cloud infrastructure, model serving frameworks. Tools. TensorFlow serving, TorchServe, Kubernetes, AWS, SageMaker. 15. Optimize inference performance. Prediction speed matters. Optimization techniques. Caching, quantization, on-an-X optimization. Example. User request, prediction API, optimized model response. 16. Secure ML systems. Security is critical. Protect. Training data, APIs, models, user privacy. Best practices. Check authentication. Check authorization. Check encryption. Check rate limiting. 17. Document everything. Document. Check datasets, assumptions, model limitations, hyperparameters, architecture, benefits. Check easier maintenance. Check team collaboration. Check audit support. MLOps in real-world projects. MLOps combines check machine learning, check DevOps, check automation, check monitoring. Goals. Check reliable deployments, check automated retraining, check reproducibility, check scalability. Typical architecture. Training pipeline, model registry, deployment, monitoring, retraining. Real-world example, fraud detection system architecture. Transactions, Kafka stream, feature processing, fraud detection model, prediction API. Alert system, technologies used area technology, backend Spring Boot, ML Python, XGBoost, streaming Kafka, database PostgreSQL, cache Redis deployment, Kubernetes, monitoring Prometheus. Best practices applied. Real-time streaming, feature validation, automated retraining, model monitoring, API security, scalable deployment. Common beginner mistakes. 1. Ignoring data quality. Poor data causes poor predictions. 2. Overfitting. Model memorizes training data. 3. Using complex models too early. Simple models often perform surprisingly well. 4. No monitoring. Production failures go unnoticed. 5. Ignoring retraining. Models become outdated. 6. Not versioning models. Difficult to reproduce experiments. Best practices summary. Start with clear business goals. Focus on data quality. Avoid data leakage. Keep pipelines reproducible. Monitor production models. Retrain periodically. Automate deployments. Secure APIs and models. Use experiment tracking. Document everything. Common interview questions. 1. What is model drift? Model drift happens when production data changes over time, causing model accuracy to decrease. 2. Why is data cleaning important? Machine learning models depend heavily on data quality. Poor data produces unreliable predictions. 3. What is MLOps? MLOps is the practice of automating and managing the ML lifecycle, including training, deployment, monitoring, and retraining. 4. Why avoid data leakage? Data leakage creates unrealistic accuracy during training and causes production failures later. 5. How do you deploy ML models? Common deployment methods. REST APIs, batch jobs, streaming inference, cloud model serving. Example ML deployment architecture. Users, API gateway, prediction service, ML model server, Redis cache, PostgreSQL. Final summary. Machine learning projects require much more than training models. Real-world ML systems include: check data pipelines, feature engineering, scalable infrastructure, monitoring, retraining, security, deployment automation. Key idea: successful machine learning projects focus equally on data quality, system reliability, scalability, monitoring, and business value, not just model accuracy.